Okay, here we go. We're going to estimate the area under the graph of this line, f of x equals 2x plus 7, on the interval from 0 to 2, using 4 rectangles, first with left-hand endpoint or right-hand endpoints and then left-hand endpoints. And I'll draw your attention to this red circle right here where I make the observation that you can actually find the exact area using geometry, because this is actually a trapezoid. These two sides are parallel with lengths of 7 and 11, and the bases, or the height is 2 rather, because these are right angles. And the formula for the area of a trapezoid is half the base, or half the height times the sum of the bases. So that gives us 18. So that's actually the exact area of this region. We're using what are called Riemann sums to estimate that area. So in this diagram on the left, we're using right-hand endpoints. Delta x is the length of the interval, which is 2 minus 0, divided by the number of rectangles that we want to use, so 4. So each of these rectangles has a width of 4. 1/2 rather, sorry. 2 divided by 4. And since we're using right-hand endpoints, we want to start at 0 and then travel out to the right 1/2, and then we'll travel another 1/2, another 1/2, and another 1/2. So I've rewritten these as x sub 1 is this point has an x coordinate of 1/2. Whoops, I'm supposed to say 2 halves here. Three halves and 4 halves. And so if we plug those numbers into the function, we will have the height of each rectangle, and that's what's indicated here. I have 0.5 plugged into the original function, gives me a value of 8, 1 plugged into the function, 9, and so on. So there's the heights of the 4 rectangles. The area of rectangle 1 is 4, half the length times the width. Same for the second rectangle. 9 times a half gives me 4.5, 5, and 5.5. If we add these all up, we get 19. That's actually 1 unit greater, 1 square unit greater than the exact area, and that's what we would expect. We've overestimated by the area of these little triangles that are above the line. Now over here, for using left-hand endpoints to calculate the height of the rectangle, again, each of these is 1/2. But we're using the left-hand endpoints. So the area of this rectangle is 7 times 1/2, which is 3.5. 4, 4.5, 5. We get the sums of the areas of those 4 rectangles of 17. That is an underestimate of the exact area because we didn't count these regions right here. And of course, as the number of rectangles approaches infinity, that is, as we let this number approach infinity, the number of rectangles, we'll get closer and closer to the exact area. And I'm going to paste in a URL to a Desmos graph that allows you to type in any function, including like a parabola, and specify the endpoints and the number of rectangles. And you might want to give that a shot. There you go. Hope that helped. If you have any questions, post a comment.